So with these problems, I recommend starting with velocity, okay? So if I look at how to determine what to put, I just look at the beginning and the ending value in that time period, and I see what happens, okay? Is it increasing, decreasing, or is it constant? All right? Don't think too hard about this. This is supposed to be pretty easy. What is my velocity here? Don't think too hard. 0. What is my velocity here? 90. Going from 0 to 90, did I increase, decrease, or remain constant? I increased. Increase. So I put a 1, or I put a plus sign down for the velocity. Good so far? All right, so if at 1 second I'm 90, what about 2 seconds? What am I at? 90. What about here? 0. Down here, negative 90. And then here, 0. Okay, so if I just look at those numbers, I start off at 0. I travel forward until I reach 90 meters per second. And then I hold for a second, and I'm traveling at 90 meters per second. And then I hit the brake, and I start slowing down until I hit 0. And I hit 0 at 3 seconds. What happens at 3 seconds? What do? I stop, and then right after 3 seconds, what happens? I start traveling backwards, right? Because I slowed down, so this is 2 to 3, I'm slowing down, 3 hits, I throw it in reverse, and I start traveling backwards, right? And I'm hitting the gas, so I'm speeding up going backwards, right? And then as soon as I hit 90 meters per second, I slam on the brakes, right? And then my velocity starts increasing, right? Because I'm getting back closer to 0. Make sense? So that's what's physically happening. All right, so we're going to do constant here, decrease, decrease, and increase. Whoop. Make sense? Any questions about that? All right, so just to reiterate, for the velocity, what we do is I look at my starting value and I look at my ending value, and if I went up, it's increase. If I remain constant, where it's the same value, it is constant. And if it decreases, then it's going to decrease. Everybody good? All right, cool. So, if I look at the position, determine if the area is between the horizontal axis and the function is above or below the horizontal axis. Now, what on earth does that mean? So this is our function here, right? And where's the horizontal axis? Right here. And it's the area in between. So on y'all's paper, it might not be dark enough. Excuse me. So that's the area that we're looking at, okay? And I want to know, is it above or below the horizontal axis right here, this blue line? So this is above, 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 below, below. Make sense? I'll clean it up. Above, 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 below, below. Cool? All right. Okay. Falling off the edge. All right. Any questions about that? Okay. So for acceleration, I like to think of myself as a little dude on a hike, and it's like Line Rider. Have you all ever played that? Little 2D thing. So am I going uphill? Is it flat, or am I going downhill? Uphill. Positive. Right? So positive down here. What do I hear? Constant. Or wait, hold on. What are my things? So I can either do a plus, a minus, or a 0. So positive slope, 0 slope, negative slope, positive slope. Make sense? Pretty easy. Okay. Okay. So areas. So I mentioned the areas above or below the horizontal axis telling us if we're traveling forward or if we're going backwards, right? If it's above the x-axis, I'm traveling in the forward direction. If it's below the x-axis, I'm traveling in the negative x, or negative direction. So if I wanted to know how far I actually traveled in that time period, I can do that. All I have to do is figure out the area underneath the function and my horizontal axis, and whatever that value for the area is, that is how far I traveled. Okay? So let's see what y'all got. What is the area of a rectangle? Base times height? You did volume. All right, remember that from geometry? Ooh, geometry. All right, what about the area of a triangle? One half base times height. Cool? All right. So if I've got a rectangle, base, and height. If I've got a triangle, base, and height. Make sense? Okay. I have a triangle. I have a base of what? 0 seconds to 1 second. How far is that? Just 1. So I've got a base of 1. What is my height? 90. Right? So a triangle is 1/2 times the base, which is 1, times the height, which is 90. So it's just going to be 1/2 times 90, because timesing by 1 doesn't do anything, right? So the area for this triangle right here is 45. So we're going to put 45 down here. Make sense? So if that triangle is 45, this one has the same height and same base, so this would also be 45. Make sense? Sorry. What about this rectangle? Rectangle is just base times height, yeah? Height is 90. What's the base? 1. What's 1 times 90? 90. Okay. What side of this triangle? Negative 90. So if I half that, I get negative 45. Make sense? And then this one has the same base and same height, so negative 45 also. Any questions so far? Pretty straightforward? You confused? Okay. All right. So this is the last part. Distance and displacement. All right. I promise this is the last thing. Distance, I just add up the numbers. Okay. Distance cannot understand what the negative sign is. It sees a negative sign and it's invisible. All right. It cannot detect it. It does not compute. So anytime that you see a negative sign, we're going to pretend that it doesn't exist when we're trying to figure out the distance. Okay. Just for the distance. Now, I designed it like this, like chart-wise, to have the addition signs in between. We are not subtracting. We are adding a negative, like with the displacement, but with distance, we add up just the magnitudes, just the numbers. So 45 plus 90 plus 45 plus 45 plus 45 is 270. Make sense? Because the distance doesn't care about the direction. It doesn't matter if I'm going backwards or forwards. It just counts the steps. It just counts the meters. The displacement, on the other hand, does care about the direction. Okay? So what this displacement is going to tell us is how far am I from my initial starting place, and am I positive away or am I negatively away? Make sense? How far am I away from my initial location? So if I add this straight out, how many people got 180? Okay, nobody did that. All right. So if you just put this straight into the calculator and don't modify it at all, 45 plus 90 plus 45 plus negative 45 plus negative 45, I end up with 90. Cool? And of course, meters. Any questions? All right.